Let us now see parameters of a FET. So, there are certain parameters of FET which we will discuss from these characteristic curves. So, you see here this one this one is a combined curve. This curve is kind of a combined curve. You see here, from here you see this curve, this is the pinch off VGS off value, and this value is the maximum value when VGS is equal to 0. We get the maximum value. So, from this curve, when VGS is equal to 0, this is the current IDSS. So, it is the same value IDSS here, the value that we are getting from this curve. I told you how to draw this curve. So, if I draw a composite curve like this, combining these two curves together, so we get this type of a curve. So, now from here, we know there are two important characteristics that we say. One is called, for a FET, one is very important, that is what is called pinch off voltage, and that pinch off voltage is called Vp, and that pinch off voltage we find it from here. This is what is the value of Vp. And then the other one is called saturation drain current, that is what is IDSS. So, thus IDSS is obtained from here. This is the value of IDSS. I told you what is IDSS also. So, these are the important factors related to a FET. One is the pinch off voltage, and another one, as I said, that is IDSS, which is called saturation drain current. So, saturation drain current, what is saturation drain current? When VGS is equal to 0, it is the maximum value of ID, that is what is saturation drain current. Okay. And what is pinch off voltage? Definition wise, when VGS is equal to 0, the point at which ID becomes constant, from which ID becomes constant. So, this point. So, this when extrapolated here, that is what is called the maximum drain current or the saturation drain current. Now, let us talk about the parameters of the FET. So, the parameters of the FET, the one parameter is called transconductance. Now, that is represented by Gm, okay, and this is equal to delta ID by delta VGS when VDS is kept constant. When VDS is kept constant. So, this is a value Gm. So, from where to find this value? If you go back to this part, if you draw a tangent, or even if you take this one, so from here you can find out delta ID, and from here you can find delta VGS. So, or else you can draw you can take a point, you can draw a tangent, and from there you can find these two values, delta ID by delta VGS. So, that is what is called the transconductance. So, that is denoted by Gm. That is one important parameter for FET, that is called transconductance. The second one is called drain resistance. And this drain resistance is denoted by RD, and this is given by equal to delta VDS divided by delta ID when VGS is kept constant. This is what is drain resistance, and this is plotted. How this can be plotted? We can go back from this curve. I told you actually these curves are not that flat in reality. They are kind of having this kind of a slope. They have this kind of a slope, and that this slope actually keeps on flattening slowly with the increasing value of negative GS. ये धीरे धीरे flat होता जा रहा है. So now if we take part from here, so this value is nothing but delta VDS, and this side I can get delta ID, and this is plotted for a constant VGS. So now here VGS is equal to 0. So if I plot this and if I obtain this, then I can obtain the value of RD. And then the last parameter for the FET is called the amplification factor. Is called the amplification factor, and that is denoted by mu, and this mu is nothing but equal to, it is RD into GM. If we substitute the value of RD, that is delta VDS by delta ID multiplied by delta ID by delta VGS. So this is equal to delta VDS by delta VGS. What is delta VGS? This is the input voltage. And what is delta VDS? That is the output voltage. You can go back. Here you can see this side we take input. So this is VGS this side and VDS is this side. So that is what we find out is it is nothing but output divided by input. So that is what is amplification factor. So we have three important parameters for a FET. One is called transconductance, the second one is called drain resistance, and the third one is called amplification factor. And this mu is actually equal to RD into GM, and this RD into GM, if we substitute the values, then that value gives VDS by VGS. Otherwise, it is, you are supposed to prove that mu is equal to RD into GM. How to prove? You say amplification factor mu is equal to output voltage delta VDS by delta VGS. So dividing the numerator and denominator by delta ID, we get delta VDS by delta ID multiplied by delta ID by delta VGS. So that is equal to RD into GM. So that is the other way to prove it. Either you go this way or you come this way. So these are the three parameters of FET. Now there are from the transfer characteristic curves, if we check from the transfer characteristic curve, we define also one important value, that is we say VGS off. VGS off. So what is this VGS off? It is the value of VGS at which ID is equal to 0. So it is obtained from which curve? Here you can see this value is called VGS off. It is that value of VGS at which ID is equal to 0. It is called the gate source cutoff voltage. That is what is denoted by VGS off. And this value is determined from the transfer characteristics, and as I told you that it is found that this VGS off is equal to VP. Okay. Now let us try to find out the expression for transconductance. Now in order to find the expression for transconductance, if you watch this curve closely, you can see this is nothing but a parabola. This curve resembles a parabola. So what we can say is that from the transfer characteristics in JFET, the relationship between VGS input voltage and ID output current is used to define the transfer characteristics. It is called Shockley's equation. This one is called Shockley's equation, and since it is basically it follows this curve is like a parabola, so we can fit this equation for that curve. This equation defines that curve, that ID is equal to IDSS into 1 minus VGS by VP, or in certain places you may find that certain books they write ID is equal to IDSS multiplied by 1 minus VGS divided by VGS off. This is also written in certain books. So this also you will find, but we know that VGS off is equal to VP, so we can very well write VGS by VP square. As a result, FETs are often referred to as a square law devices. So now we have this equation for FET. ID is equal to, we have ID is equal to IDSS multiplied by 1 minus VGS by VP square, where IDS or IDS or ID, whatever we write, it is what? It is the drain current, and IDSS is what? It is the value of IDS when VGS is equal to 0, and VP is what? VP is the pinch off voltage. So let me give this equation number 1. Okay. Now from equation number 1 we can obtain an expression for GM. For this purpose, let us differentiate the equation with respect to VGS. So delta ID or IDS, whatever is they are the same. I write ID or IDS, they are the same, divided by delta VGS. This will be equal to IDSS multiplied by 2 into 1 minus VGS by VP multiplied by minus 1 by VP. हम इसको differentiate कर दिए with respect to VGS. So this is what? This is nothing but equal to GM. GM is equal to minus 2 IDSS divided by VP multiplied by 1 minus VGS by VP. This I am giving you because there may be a few numericals based on this formula as well. Let me give this equation number 2. Again from equation 1, we can write 1 minus VGS by VP. This is equal to under root IDS or ID divided by IDSS. I can write this. Now substituting this value, this 1 minus VGS by VP equal to under root IDS by IDSS in equation number 2, what we get is GM will be equal to minus 2 under root IDS into IDSS whole divided by VP. I substitute this value here, right? So what happens is this under root IDSS, this one, it makes IDSS, this VP stands here. So we get minus 2 under root IDS into IDSS divided by VP. Let me give this equation number 3. Okay. Now if say we write GM is equal to GMO तब लिख रहे हैं when VGS is equal to 0. When VGS is equal to 0, उस समय हम GM का वैल्यू अगर GMO ले लें, so then what we can write is GMO, this is equal to minus 2 IDSS divided by VP. This I obtain, this value I obtain from equation number 2. From equation number 2. This value I obtain minus 2 IDSS by VP. I substitute if I take GM equal to GMO. So let me give this equation number 4. So then from equation 2 and 4, from equation 2 and equation 4, what we can write is GM is equal to GMO multiplied by 1 minus VGS by VP. Let me give this equation number 5. Now, equation number 3 shows that, equation number 3, if we go back to equation number 3, equation number 3 shows that GM varies as the square root of the saturation drain current IDS. GM varies is directly proportional to the saturation drain current IDSS also. And equation 5 shows that GM decreases linearly with the increase of VGS. Equation 5 में अगर हम जाते हैं तो it shows that GM decreases definitely linearly with the increase of this value VGS. So these are the two materials that we obtain from the expression of the FET, that is IDS is equal to IDSS multiplied by 1 minus VGS divided by VP whole square. वहाँ से these are the informations that we obtain, right? So this is what about your parameters of JFET. So we obtained the parameters of JFET in this particular lecture. Thank you very much.